Hello, everybody, and welcome to your pre-lab for your saltwater-powered battery lab. So, what we're going to do today is I'm reading through the lab. I'm going to talk about the overview and the purpose, go through some of the materials, as well as the just general safety concerns that go along with those. We'll talk through the procedure. We'll draw out the procedure. That way, you feel nice and confident doing and running this lab. So this whole unit has been about energy. Your final project in this unit is a energy lab. So what you are doing is making a saltwater battery. A saltwater powered battery is a type of environmentally friendly battery that uses salt water, which is exactly what it sounds like, a solution of salt and water, as part of its electrolyte. Now, the electrolyte is the substance that allows electrical charge to move between electrodes. Now, let's remember that vocabulary term. Electrodes are going to be our metals. So remember, in a battery, we have electrons flowing between metals. The salt water is the electrolyte, or the solution that allows those electrons to flow. Now, your batteries are going to have two electrodes, a positive and a negative. Those electrodes are separated by the saltwater solution. When the battery is discharging or producing electricity, the ions or the charged particles, and we know what those are. Those are electrons, move through the salt water between the electrodes, while the electrons flow through the external circuit, providing a device, powering a device. Your task is to maximize the efficiency of the battery by using various combinations of electrodes and salt. So this last sentence is really your goal. You are trying to make the most powerful battery possible. All right. The materials you're going to have in order to do that. So you're going to have a beaker, and this is our normal size beaker. It's going to be 250 mils. You only need one. And then you're going to have some electrodes. So there's going to be copper, iron, and aluminum and zinc out for you to use. Salt, normal table salt, water comes from the sink. The Lab Quest. This is essentially our lab computer. It's going to read the output of the voltometer, which is your probe. The alligator clips are actually going to be connected to the voltometer up here. You need a glass stir rod in order to stir your salt into your water. You need sandpaper to clean your electrodes, a scoopula to move the salt, and a scale to measure out the salt. Okay, most of these materials are what I call kitchen materials. So salt, standard table salt, water, normal water. But safety wise, you still need to be following lab safety procedures because of the glass. So the beaker and the glass stir rod are made out of glass. All right, procedure. So I'm going to read through it, we're going to talk through it, and I'm going to draw it out. First thing we are going to do is obtain a 250 milliliter beaker. We are going to fill that beaker with 200 mils of water. Okay. So remember, beakers are the ones that look like cups, and we are going to fill it with water. up to the 200 line, which is going to be pretty darn full. All right. We are going to add 10 grams of salt to the water. Now, you will need to mass this salt out on the scale, and you will need some sort of container to mass that out. I would probably recommend using a 50 milliliter beaker to do that. So I'll add that here to your blank spot. But you are going to need to mass out 10 grams of salt on the scale, and you're going to need to stir that in. This will be my symbol for stir. All right. Then, step 4, clean the metals with sandpaper. So, metals oxidize or react with oxygen at when they're sitting just out in the normal out in the room. So, you're going to grab one of each of the metals. So, you're going to need a strip of aluminum, a strip of zinc, a strip of copper, and a strip of iron. Most of the symbols are pretty intuitive. Iron is different. So iron is Fe. Now, these are going to look similar, so you're going to want to make sure you keep them straight. Aluminum, zinc, and iron are all going to be silver colored. So you can color those in like pencil colored. Copper is going to be a little bit more identifiable. That's going to be your typical, like brighter brown color. Except that's a pretty bad brown. We'll do gold orange combo. And you're going to take a piece of sandpaper and you're going to clean all of them. Okay. We're going to start by placing the copper strip and the zinc strip in the saltwater solution. The strips cannot be touching each other. So for trial 1, we are going to use copper and zinc. Doesn't matter where they're at in the beaker so long as they are not touching. Now, we're going to use this drawing for all trials, so I'm just going to put these generically as metals. Electrode 1 and 2. Okay, so the battery is set. Make sure, again, cannot touch. Now we've got to hook up the voltometer so that the electrons can flow and we can measure that flow. So we're going to attach the alligator clips to the metals. So those are the clips connected to your probe. The probe is going to be connected to the lab quest. So I'm going to have kind of a convoluted screen. We'll have a box, that's the voltometer. And then that is connected to a slightly larger box, which is your lab quest. And that LabQuest must be plugged into the wall. They have a battery life of like 20 minutes. So make sure that is plugged in. Plugged in. Okay. So we're going to connect the voltometer to the strips. Mine will go this way. Whee! And there's two clips. If the clips are on correctly, the voltometer will register a reading in volts. We want that reading to be positive. So we'll say 0.324 volts. If that reading is negative, switch the clips. But make sure that reading is positive. We're going to record the voltage in our data table. So back here, I would record the number, and don't write this down because this is not your actual voltage, but I would record whatever number pops up on the screen. Now, this number will not stay consistent. It will jump around. That's fine. See where it kind of levels out and trends out, and then record that voltage in here. All right, trial 1 done. Step 8, repeat the procedure using various metals and saltwater solution concentrations. You will need to make sure you rinse and dry the electrodes between each trial. When you are done with the metals, return them to the front. None of these get thrown away. These are all reusable. Now, for the batteries, you have specific criteria to meet for the first 6. So trial 1, we drew out 200 mils of water, 10 grams of salt. We're using copper and zinc. Trial 2, same amount of water, 20 grams of salt. So you're going to need to make a new saltwater solution, still using copper and zinc. Battery 3, same thing, except now we're using 5 grams, copper and zinc. For battery 4, we start changing another variable. Here, we're keeping the amount of salt consistent, but we're changing the electrodes. Now, instead of comparing copper to zinc, we're going to compare copper to iron, and copper to aluminum, and aluminum to iron. For each of these, you are going to record the voltage that goes with the battery criteria. For battery number 7, this is a challenge. I want you to try and maximize the voltage using the materials provided to you. So now you get to pick. What volume of water should you do? What mass of salt do you want to try? What electrodes and metal combinations do you want to use to try and maximize or get the highest amount of voltage possible? And then for your post lab, you are going to be answering some questions. I would go ahead and make sure you're meeting the requirement clearly stated, 2 sentences each. So I've got, let's zoom out. Nope, I'm zoomed out as much. I gotta move the neck. I've got 1 through 2 marked on each of those. But that's your pre-lab. After this video, you should have a good understanding. You should be ready to walk into lab and make some batteries.